What's up, guys? Welcome back for another video from Matt's Math Tutorials. Today we have an AP practice problem from the free response, like no calculator part of the test. So let's just get into it. Alright, let f be the function defined above. Fx equals all this. So it looks like we gotta have a piecewise. We have this part for -3 to 0, and then 0 to 4 that part. Alright, find the average rate of change of f on the interval -3 to 4. So average rate of change, that means we only need, f can be something like this, whatever. We only need the first point and the last point. And then we just want to find the slope between those points. So let's plug in -3. So we would plug that into the first equation. So we would have root 9 minus -3 squared. Of course, that's root 9 minus 9. So that's 0. So we'll do rise over run. So y2 minus y1 over x2 minus x1. So we know that x1 is -3 minus -3. And we know that y1 is apparently 0. So now we plug in 4 into this one. So we have -4 plus 3 cosine pi times 4 over 2. Pi 4 over 2. So that's going to be -4 plus 3. So cosine, well, I'll just write out the whole step. Cosine of, that's going to simplify to 2 pi. And of course, -4 plus 3, cosine of 2 pi, that's like this angle, cosine 1, and then like 2 pi. Yeah, so cosine, that is 1, so -4 plus 3 equals -1. So we have y2 is -1, and x2 is 4. 4 minus -3, which equals a -1 over 7. So the answer to A is the average rate of change is -1 over 7. Because again, that's the slope from the first point to the last point. All right, write an equation for the line tangent to the graph of f at x equals 3. So we're going to want y minus y1 equals m x minus x1. So we're going to find the point. This is going to be f of 3. This is going to just be 3, and this will be the derivative, well, the value of 3, for the derivative of f. So f prime of 3, I guess you could say. So what is y of, or f of 3? Well, plug 3 in, that'd be -3 plus 3 cosine, yeah, let's write this out, -3 plus 3 cosine of 3 pi over 2. So that would be, think about 3 pi over 2, pi over 2, 2 pi over 2, 3 pi over 2. So it's right here, cosine of that is 0. So this whole thing is 0. So we just have -3. And then we already know x1, so then we have to find the derivative. So x equals 3 is going to be in this part right here. So we just have to find the derivative of that part, which would be what? -1 plus, let's see, inside. So that'd be 3 pi over 2 times negative sine of pi x over 2. Okay, so now we have to plug 3 into this. So that'd be -1 plus 3 pi over 2 times negative sine 3 pi over 2. Right? Looks like it. Okay, so that would be -1 plus negative sine 3 pi over 2. Sine 3 pi over 2 is right here. That's -1, so that's just 1, basically. So -1 plus 3 pi over 2. Just kind of keep it like that. So that is m. So let's do this. Y plus 3, right? Because y1 is negative 3 equals negative 1 plus 3 pi over 2 pi over 2 times x minus, what was it, 3. All right, let me just, make sure that that's right. That is correct. Okay. And so is the negative 1/7. Great. So, easy. This is A. That's B. I don't even know why I'm trying to draw these shapes. All right. So, those two are done. Find the average value of f on the interval negative 3 to 4. So, average value is going to be the integral of the whole thing, right? The integral from negative 3 to 4 of f of x times 1 over 7 because it's the average. So you're saying this is like 7 units long from negative 3 to 4. So you're going to do times 1/7. This is the formula that you should learn for average value. And you can kind of think of it as like an area and then a rectangle. But so let's draw out this graph. Now I don't know exactly what it looks like. It's going to be something like this, right? Negative 3 to 4. So this first part should look familiar. This is, in fact, the equation for a circle. Because if you think of this as equaling y, then you square both sides, and you add x to that side, it'd be 9 equals x squared plus y squared. And that's a circle of radius 3. So this part is something like this. And the next part, cosine would kind of do this, but then the negative x kind of makes it goes down, I think. So it's going to be something like this, right? So we want the area of this. So this part is just going to be a quarter of a circle. So this is pi r squared over 4. And then this part, you can just do an antiderivative. So r, by the way, r we know, like I said, is 3. So this would be 9 pi over 4 plus, so we need the derivative, or the antiderivative, so integral from 0 to 4 of just this part, right? So negative x plus 3 cosine, negative x plus 3 cosine pi x over 2. Wow, I don't even know what I was doing there. Dx. Okay, so, and if you're looking for antiderivative of this, of course, this is just negative x squared over 2, right? Because that would make negative x. And this one, a little bit more complicated. So we're saying, let's see. So if antiderivative, it's going to be sine. Something sine, right? So it would be sine, and then would it be 3 pi over 2x? Let's try this. So if I was going to do the derivative of this, it'd be cosine times that. So no, it would not be. It would be this divided by pi over 2, right? Because that's going to go, this whole thing is going to go to the outside when you do a derivative, but we only want the 3 to stay there. So I believe our antiderivative is negative x squared over 2 plus, what, 2 over pi sine 3 pi over 2x 0 to 4. Is that correct? That feels off. That feels like a weird answer. Because this is a no calculator part, right? Yeah. So, let me see. This is not correct, I don't think. Let's see. Oh, right. So, this stuff is all going to stay in here when you do the derivative, which we do not want. So, the inside actually has to stay the same. I knew I was doing something wrong with this because there's no way you would have all that there. But this has to still be pi x over 2. But then when we multiply by that, it's going to have to be equal to 3. So that we have to just add stuff here, basically. So we're saying pi over 2 times something equals 3. Looks like k is 6 over pi. So this is 6 over pi. So let's just write that out neater. Negative x squared over 2 plus 6 over pi sine pi x over 2 from 0 to 4. Now is this right? This one is correct. Okay, so now we can evaluate this. So let's see. Evaluate at 4. X squared, 4 squared is 16 divided by 2 is 8. So we have negative 8 plus, let's see, that's going to be 2 pi. So that's all going to be 0 because sine of 2 pi is 0. So negative 8 minus, plug in 0, that's part 0. This is going to be sine of 0, right? So is this whole thing just negative 8? Looks like it. Okay, so yes, minus 0. So this part is negative 8. So what was this part? This part was only the area from 0 to 4. So we have to now add this area, which was 9 pi over 4. So we have 9 pi over 4 minus 8. So this is the area of the entire thing, right? But now we want to multiply by 1/7, which is, of course, the fraction of the thing, of the interval length. Negative 3 to 4 is 7, so we want to multiply by 1/7 to get the average value. So this times 1/7. And this is our answer for C. And that is correct. All right, so that's an important formula, the average value thing. This is basically just what we do. We just split this up into two separate integrals because it's two separate functions basically, so you can't really do them as one together. All right, C is done. What's the real value of x at which f(x) attains an absolute maximum on the closed interval? So, an absolute maximum. So, what would it mean to not attain an absolute maximum? Well, it'd be like if there was an asymptote, right? Something like that, or a hole, right? Something like that. But it looks like, so it looks like we're gonna have to see if this is continuous. Because if this is continuous, then I'm pretty sure there has to be an absolute maximum. Just from kind of thinking about it, you know, how can you have a continuous function that doesn't have an absolute maximum somewhere? You know, that one has it right there. The only way I can think is if it's like an asymptote, right? Or it's a hole, right, where the hole would be the maximum, but like these kind of just approach the maximum. But let's find out. So to find out if this is continuous, we have to plug in 0, right? We have to plug in this kind of transition number, 0 and 0, into both and see if we get the same value. So that would be what? Root 9 minus 0 equals 3. And then negative that, well, that's 0 plus 3 cosine 0. Cosine 0 is 1, so that equals 3 as well. So it looks like we're good, right? So it looks like this is yes, because it's continuous. And without any holes or asymptotes, you're not going to get a function without an absolute maximum on this interval. So yeah, again, it'd be different if it didn't include, if it was negative 3 to 4 non-inclusive of the endpoints, because then if you just had it like go up like this at an endpoint, right, it's going to get infinitely close to that. But that is not the case because we are including it. So I believe this is enough to show. So hopefully this one wasn't too bad. If you're taking the AP Calculus BC test next week like I am, or any AP test, good luck. I believe in you. You can do it. And yeah, I'll see you next time.